Okay. Okay, same thing we are developing now. Same thing we are developing now. And if you completed, okay. If you not completed, then also okay. Who completed, they will understand very easily now what we are discussing. Okay. Here I am opening PPT now. Okay. Now we today we are discussing seven segment displays. Seven segment display. What is we will discuss what is seven segment display and types of seven segment display. Okay. Then how to display digits on seven segment display and calculations of seven segment display we will discuss. Okay. Okay. We will discuss these things. Okay. First of all, we will talk first we will talk what is the seven segment display. Seven segment display is a seven LED developed with the help of seven LEDs. This type of displays are seven segment displays. Okay. Seven segment display widely used in embedded system display digits in and some character. Here we will display seven segment displays. Here we will display numbers and some characters. Okay. And applications. Here our people are mentioned commonly found in digital clocks and timers. They are used for traffic signals. Okay. Displays time to display times, malls and services center to display foot counts. Okay. And token numbers. It contains seven segments which can be turned on off individually. That's why I focused more on LED. I explained you more on LED. Why means these seven segment display each line represent individual LED and represent individual LED. Okay, just 1 minute. These seven segments we will use individually. These seven segments we will use in each line we will use individually. Here also initially they used filaments and vacuum fluorescent bulbs. Now they see the advantage of light emitting diodes. Okay, so they added here in line each line they added seven segments. Okay, and each line they given labeled as ABCD. They given names as ABCD EFG. All these segments used to display digits and few characters. Remember this word, few characters. And I will show you in Proteus. I am explaining you 7 segment, but in Proteus we have 16 segment also. In Proteus 14 segment, 16 segment, different variants also available. Okay. And dot point segment, DP, is also available. Okay. Each of the segment is made up of glow by making the respective LED forward bias. Okay, LED is developed with the diode and forward biased. If it is forward biased, it will glow. There are two types of 7 segment displays: common cathode and common anode. These are the connections. Types of there are two types of 7 segments are there. One is common cathode and common anode. These are the two connections. Just observe top and right side, right direction. We will take the values A, B, C, D. Here, right direction, we will take the values E, F, G. Okay, here dot point. Last one is the dot point. Okay, common anode. Here also we will take this direction and we will give this one. Okay, as shown in the figure, common cathode type of 7 segment display. All cathode pins are connected. Pins are terminals of made common and connected to supply ground. All are connected to supply ground. Okay, turn on any segment anode. Particular LED has made high, either control from controller or switch. Okay. Common cathode type of 7 segment displays. All anode pins terminals are made common anode pins. Here in cathode, common all 7 LEDs cathode pins are common. Here common anode pins are common. Okay. Here common cathode. Okay, here we will make high all ones. If we make all ones, then it will be high, otherwise it should be low. Okay, so we will use this process. These values we will give here, and they will give the following table is gives the details of different statements 0 to 9. Okay, the common cathode displays controller display digits. Okay, the pins of controller should be made high and to turn on the LEDs. Turn on the LEDs. Okay. Okay. And common anode is we will take in common cathode we will take high display. Okay. In common we will take common anode, we will take low 0. If we want to on LED, we will use 0. Here we will use 1. Okay, multiple displays are available 0 to 9. This is the yesterday given values to you: A, B, C, D, E, F, G. And here if you want to on this one, here you need to make these LEDs on. Okay, here if you give 1 in common cathode, you have to give 1. Common anode, you have to give 0 in on position. If you are using common cathode, you have to give 1. Common anode, you have to give 0. Okay. So we will see this one more clearly in manual. Okay, here digits. Okay, in common cathode, just observe here, we are connecting 7 segment pin, port 1 pin. Okay, we will connect any port, just take any port. These are the segmentation values. A, B, C, D, E, F, G, H. Okay. Here, common cathode. Just see the common cathode values. Here, A, B, C, D, E, F. Okay. I want to blink all these. I want to blink all these LEDs in 7 segment inside the 7 segment. So I am giving ones to all these one. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. Okay. Here A is 1, B is 1, C, D, E, F. Here G is 0. G is 0. And this is the uh, dot point mm, dot pin. Okay. All this. Okay. This is a dot pin. We are missing, we are leaving this one low. Okay, this for 0. Same way we developed for 1. Here first one, A we are not turn on A, so we will give 0. We turn on B, C. Only B and C we given 1. Right? Okay, B and C we given 1. Remaining all are off. Okay, remaining all are off. Okay, next like that 2, 2 only, A, B, C, D, E, F. F and C, only F and C will be off. This SC, in the C 0, and in F it's 0. Only F are zeros. Here E and F. E, these are the, this is E and this is the F. These two are off. Like that. A, here A is off. First one is the off condition. Here it is off. Next these two, uh, B, C, D, E, D, E. These are the off. Remaining are 1. So everyone just make these 4 just here like this. We developed all values up to 9. Okay, up to 9, 0 to 9 we developed these values. Okay, and now just observe here, just observe. I will take first random, then will take 5. Okay, I am taking 4 bits individually, just 4 bits individually. Okay, this is the value. Here I'm taking these 4 bits, left side 4 bits first. Okay, left side 4 bits and right side, left side 4 bits and right side 4 bits. Okay, this is the, what is the value of this? It is first, this is the 1, this one is 1, 2, 4, 8. 1, 2, 4, 8. It is 2 power 0, 2 power 1, 2 power 2, 2 power 3. Okay, 2 power 3. This is the values. Okay, this here first it is 1, 2, 4, 8. So if you count total values, it comes 15. Okay, so in this we will use 15 values. Okay, just here 2 and 4, it is 6. Here we are using 6. Here 6. Here this is the D value. Here 1, 2, 4, 8, 13. This the value 13. 13 is D we are using. Just I am opening. Just observe here. 13. D means 13. Okay. For up to 9, we will use 0 to 9. We will use values. A to 15, we will use A to 10 to 15. We will use A, B, C, D, E, F. Okay, these values in hex. 13 means D. We are using. That's why here we are using D. Okay. In previous 7 segment also like this we used different values. Here total we generated 10 values. Total we generated 10 values. Okay. Total we generated 10 values. This is up to here. Everyone clear? Up to here. Everyone is clear how we are generating these values and why we are making one. Everyone is clear? Just type yes. Just type yes. Then we will go for schematic design. Okay. If you have a doubt, still you have a doubt, I will explain in there also. I will explain once again. I will explain there also. I will explain once again. Okay, I'm creating Proteus VSM page, new project. Here I'm taking 7 seg with 8051 project name. Okay, next I'm creating next. Okay, I'm taking A3 page type. I'm not creating PCB. I'm creating firmware. Here 8 family 8051. Okay, microcontroller 89C52. I'm selecting 89C52 microcontroller in 8051. Keel compiler I selected. Next, I'm clicking next. Finish. My project is page is developed. Okay. Here first I'm making connection. Okay, I'm making connection. Here I'm connecting. So before picking 7 segments, I will show you other 7 segments also. Okay, here just I'm typing seg here. Just see here. This is the 14 segment. 14 segment. Here we are learning 7 segment. We are learning 7 segment. It is 14 segment. Inside 7 segment, it have 14 lines. Okay, this is the 14 segment. This is the 16 segment. One. I will open 16 segment one. This is 16 segment. Like if you, it is 16 or 7 or 14, you have to take every time A to B. You have to take A, B, C, D values. Okay, A, B, C, D, E, F up to 16. You have to give names. Okay, and which pin should be on? You can take that pin is 111 for common cathode. Okay, like that we will do. So same process up to 16 segment, 14 segment also same process. Okay, same process we will do 16 segment or 14 segment also. Now this is 16 segment, this is a 14 segment, one digit. Just see 14 segment, same blue color. I selected same blue color here, green, red. 14 segment. This one is the 14 segment. 14 segment. Okay, this one is the 14 segment. 14 segment. So these are the different. So if you worked with one keel, we are using keel compiler. Okay, these are the 7 segment, 14 segment, 7 segment, 14 segment, 16 segment. Okay, these are the 7 segment, 14 segment, 16 segment. Now I am explaining you 7 segment. Okay, if you have a time, if you have a time, students, please don't call me when meeting is going on. Just don't call me. Okay, I will call you. Just text me. Okay. Okay. Now I am explaining you 7 segment. Okay. Here in 7 segment also, this is different 7 segment. It is blue BCD. We will get BCD code uh, in in encoder decoders. There we will generate BCD code also. Okay, encoder decoder. Okay, there we will generate BCD code also. Here this is BCD 7 segment. These are different 7 segment. Okay, now common cathode display. Okay, I'm selecting red color, common cathode red. Okay, I clicked on this. Okay, I clicked on it here. Just I'm giving extra space. Okay, okay, this is the here P1 in here in manual which port he connected. It's 1 minute I'm checking port where he connected. Okay, just everyone follow manual also. Okay, I'm copying source code from manual. Okay, I'm copying source code from manual. Okay, here we required up to here only. Here only ash include register copy. Okay, I copied the source code. Here I'm copying so same source code. Just I'm copying there. Here up to here it is in source code. Up to here it is here it is delef code. Okay, here I'm connecting. Just I'm checking the port 3. I'm instead of connecting port 1, connections are this direction. So I will try to connect here port 3. Okay, same code, only one modification I'm doing, only one modification. First I will do, it is working fine, then I will tell you. Port 3, okay. I'm compiling, I'm running the code. It's working fine. Okay, only in source code I changed the P1. Instead of P1 I used port 3. Why means connection. Okay, due to connection, easy connection, I make port 3. You can also in manual they mention port 1 here. Port 1 here I used port 3. Okay, if I change one number in code, I changed only one number, only one place, but total schematic is changing, just understand. If I used here P1, here if I am using P1, my schematic, it don't works. We need to develop source code in different form. Okay, I'm here just this one connection. I'm picking terminal. In terminal mode, I'm picking ground. I'm connecting ground. Okay. This is they developed in schematic design. Okay, this is the connection. This is the connection for 890 fiber. Okay, just try to develop this one. Okay, and so just I shown you P3 after session, after the session, after session, just take time, practice the with different ports. Here I am showing in manual they mentioned P1, I shown P3 also. You can take P2 and P0 also. After the session, try to connect with other pins, other ports, and change the source code accordingly. Only this one we need to change, only this one. Here P1 place, in place of P1 we are using different values. Okay, and source code also, how we develop these three, 4F. First one 0, 1, 2, 3. 3 is 4F. Just I am checking. 3 is 4F. 3 value. Here I am common cathode source code. Here I am checking. 3, 4F. 3 is 4F. Here 3, 4F. Okay. Here, why we are using array source code? Here in source code, I am discussing one concept in source code. Here we have in here we have 000 values, so we are converting these 00s into hex value. Okay, and here in programming array is used for array. In programming language, array is used for uh, array array is used for array saves the similar type of data. Array saves the similar type of data. So we are making, instead of giving every time, instead of giving every time, here we created one array. Here we first initialized array. We initialized one array. So array means we created 10 blocks. We created 10 blocks, and in 10 blocks we are placing, this is standard data. What we created, this is the standard data. If you used any project, this is the standard data. Okay, just understand this one. Some student, computer science student messaged me personally, and he asked that, sir, I am computer science student, why I used why need to I used these all these circuits and all these things. Okay, so for him I am explaining, it is compared to ECE triple students. If you understand source code, you will, computer students will benefit more than ECE students and triple students. Here schematic, here in project schematic, this schematic development. Uh, okay, job opportunities. I will, after this project I will show you one PPT, not PPT, one image. I will show my one of my director, he shared with me one image. I will show that image, how we develop project. I will share with you that image. Okay, he told me that image. Here schematic capture is one. Here what we are developing these connections, this is developed by EC students. Source code project, here we CSC students will do the source code coding. EC students will do, triple students also do, MCA students also do, embedded system. If just open any Naukri portal, just to see there, they will mention MTech students also, embedded systems, MTech, like MCA students also, they will also do the embedded programming jobs. If it is embedded system job, they also do the programming. Okay, this is the standard data. Remaining source code, this is the standard data for seven segment. So if you use this standard data, you can develop your own logic to execute the project. You can use, this is the standard data up to what, for 0 3f. If you remember this value, you can, I told you how to we are developing the 3f value, but this is the standard data. Okay, this is the standard data. So if you save this data once, you can, in any seven segment, common cathode seven segment, you can use any common cathode seven segment. Okay, and okay, this is the only this one we are connecting to the microcontroller. Okay, and remaining is C code. Remaining is total, only P1 is controller. Remaining everything is C code. So computer science students also develop this is C code here. Okay, we are giving one type of data. They are doing, controller is processing that data. Here we are giving, this is the, you can take this P1 is a variable. Think P1 is a variable. We are providing one value, 8-bit value. We are providing one P1 variable. So P1 is processing. P1 is processing there, and it's showing some output. Okay, so this is the logic here. If you are computer science student, you will understand compared to our ECA and triple E students. I am also background from ECA. Compared to ECA and triple E, CST students will understand code logic. But these are the few things are standards. These are the standard data. We don't change this data. So only the logic will change. Okay, so it is very, easy. It is very easy to develop. For computer science students, it is very easy to develop source code. Okay, compared to ECE, triple E, you will learn, CSE students will learn two languages extra. At least two languages you people learn extra. Only ECE students will learn only C. We will learn C and ASM and circuits more. But you will understand more programming languages. C++, Java you will learn. At least you will touch the Python. ECE students, maximum students don't touch the Python. Okay, if you are using any programming language, this is the standard data. Here what we created in, before seeing this seven segment, this is the standard data. If you using common cathode, you have to use these values only. How only you have to use these values only. Okay, for 8-bit you have to use these values only. Okay, so in companies also, 90 per embedded systems jobs will, computer science people also do the embedded system source code development, developers, source code developers. It is one job opportunity. Here this option, here I am moving, this is one job opportunity, source code developers. Here this is the embedded hardware engineers. If you understand everything in schematic, you will get the job opportunity. Source code engineer, embedded hardware engineer, source code. If you understand this coding part, okay, you can try to get job in source code developer, embedded source code firmware engineer. Okay, firmware engineer, source code developer, hardware engineer, and PCB layout designers. Okay, that is the different streams. Okay, PCB designers. Then purchase department. If you understand BOM, bill of materials, you get purchase department, job in purchase department. Okay, these are different streams of jobs. Here we are doing all together, but schematic designers, according to the company, schematic design team is different, source code development team is different. In India, we are working more on source code development. Okay, so you can, now you have to tell me, is it useful for CSE or not? Okay, and frankly, compared to ECE triple E, if you are now IoT concept, if real time market using IoT, they used, they, you understand, CSE people will understand database, database and cloud computing, all these things, cloud related information, and HTML related information. Compared to EC students, you have more knowledge on that. Okay, so here we are doing, this is firmware. We will connect, if you know you have HTML knowledge, we will give these same values, data values. We will take the data values from URL. We will take data values from URL and we will apply here. Like that, we will develop different concepts. Okay, this is the standard data. Only here we are this is the standard data. Remaining logic we are developing. We are using array. Why we are using array? It is totally, it is totally, it is totally similar data, similar type of data. That's why we are saving in array, blocks of array, and we are using the same data. We are calling the data every time when we required. Okay, we are not processing here. Okay, this is the concept. Just everyone try this schematic design, then add the source code, develop the project. Okay. One student. Yes. CSE students also do the source code development, but we don't know. We don't know 90% concepts, programming concepts. We not touched in our education system. In, we are not tree concept. It is there in tree concept is there in tree concept is there. We not we not learn that tree concept in college times. Okay, company organization, they will, CSE students will learn that concept. And queue stack, queue and stack, queue and stack is two concepts are there. Those concepts are, we don't touch in education in colleges, college time, but in real time we will use that queue and stack project. Different scenarios we will use those concepts. Okay. uh, for example, queue stack we are using. You data structures means you only, we will learn six sorting techniques and very few concepts we will learn. But real time using, we don't use anywhere, we don't use anywhere. Okay, so that is the advantage. Just that is the advantage for them. Schematic design, we have advantage in schematic design. Hardware development, okay, everyone have their own advantages. Few people will learn end to end. Yes sir, develop this schematic design. So if you are CSE student, now if you learn hardware, you will get, it is extra added advantage to you in resume and in in companies. It is extra advantage to you. Okay, in India we are working only uh, in India we are working only softwares. We don't develop hardware mobile. We don't develop any hardware in India. We just dump it from other countries. Okay, we will develop here source code. 90% companies, they don't know source coding, how to develop source code, how to develop a concept into programming. Indians will do better compared to other. Please. So just one student asked me, sir, I'm CSE, why should I learn this all these seven segment? Here you are using same source code. Okay, processing unit. You will understand how computer is. If you understand one controller concept, you will understand how that computer works, how servers work. Okay. If you learn Linux, now booming concept, embedded Linux. Everyone learning embedded, interfacing with Linux. Embedded Linux, this is booming now. Everyone, they get, if you know embedded with Linux, you will get very good options outside. Okay, in that they are adding embedded AI, embedded AI, artificial intelligence based embedded systems. They are developing that. Okay, okay, please everyone develop this. Then if you completed this one, add source code and check the values. Okay, please complete this project. Please, students, I'm getting calls from unknown numbers. Please don't call on this. If you faculty, please send message, sir. Please, sir. Send पहले मैसेज कर लो बाद में कॉल कर लो सर आई विल लिफ्ट कॉल प्लीज Please complete the source code development. This is the source code. Just try to change the p value here, p1 value with a different port, connect different port and check the connections. Okay, check the connections. Please everyone complete. Who are completed, just try to develop a logic for two 7 segments common cathode. This value is same. So here we are using this value same. We are taking, okay, just see if you get any error. See which 7 segment you selected. Okay, who are completed, just think to develop, use to connect two 7 segments. We are connect two 7 segments and we will generate 0 to 9. Okay, 0 to 99. We will develop 0 to 99 with two digits. Okay, value 0 is lowest value, 99 is maximum value. How to develop logic? Just think the logic. Okay, just think the logic. Who completed the concept? Just to think the logic and try to develop here. Okay, try to develop in Proteus. Okay, who completed? I will ask you. If you develop logic, you get the output, just show me. I will explain you. Who completed, just think that. Who are not completed, just complete very fast. Okay, this is the schematic design. These are the components we used in, only two components we used in Proteus. Okay, just complete everyone. Sukanya Bharati. Just what happened? If you completed or you are still facing problem, just text me in chat. Okay, I am selecting 7 segment. I am not doing any changes, just a color change. Common cathode here, common cathode. Single common cathode. First I am selecting green, then I am selecting blue. Just I am replacing. If you work with one color, it is enough. That's values is no, don't change. That is standard values. Okay, those are the standard values. Uh, Next I am changing color green, blue, and stop the simulation. I'm not changing the source code. I'm changing the just hardware. Okay. For same, it is using same concepts. Okay. Here. Okay. Please, everyone, complete the to how to. Okay. This is the. I'm changing the LEDs every time. I picked common cathode green, red, blue. Now I'm using green. Next I will use blue. Same, same. Okay. I'm not changing. So I'm not touching even source code also. Okay. I'm not touching source code also. Yes, I'm changing the hardware. It is working. It's also working fine. Okay. Okay. Just think these. I'm using red inside and placing red glass. Just please everyone complete this very fast. Okay. If you are CSC student, just develop here code for two digits. Here I am using P1. Next I will use two digits. Okay. How to develop how to use the same code for two digit. If you have any, always think your own. Always think your own and send me. If you have any plan, just send me. I given my mail ID and you know my contact number also. Send me how you develop the project. Okay. Try to develop your own first. Okay. Please complete remaining people who are completed think that who are not completed just complete this first learn single one then go for multiple seven segments. Okay. First you complete single one. Okay. I change this code source code. Just sorry. Please send message in chat if you completed project. If you completed this project in chat, send message done. Please. Okay. Okay. Next, we have many options. Okay. We have many options. Okay. We have many options, many ideas. Here, every concept is here. We have other options also. We need to connect extra 7 segment. I want to use two 7 segments. Okay. Okay. Next concept. We are discussing next concept. I want to connect another seven. I'm stop the simulation. Okay. I want to connect uh, like this. I will connect 1 7 segment and I will make them continuously. Okay. This is one option. I will connect. I will connect. These all are all pins. Okay. Like this, I will connect. Okay. And I will blink. This is one option. And two values. I want to print two values. So this is one option. But in Proteus, we have 7 segments. We have here we have this is we have this IC. Okay. So here we have one more option. This is one option. First I'm deleting this. Okay. First we have this option. We can connect two 7 segments. Okay. We will move side by side. Okay. We will move side by side and we will see the values. This is one option to develop two 7 segments. Okay. Next another option we have. We searched in Proteus. We have one IC represent shows like this. Okay. Which one is better? This one or this one? Here we are using seven connections here, 7 connections for here, another 7 segment. So here we are using only first 7 connections, 8 9 10. Only we are using 10 connections. Okay. So here we are decreasing around 6 connections. We are decreasing around 6 connections. Okay. Here this is 7 7 9 7 8. Here 8. Here only 10 connections we are using. So we are reducing 6 connections. So we are using this is a better option for developing the this is better option for developing the next project. Okay. So I am following that option. So in manual also they mentioned same concept. They mentioned the same concept here. Okay. Okay. So now we are going to develop this one. Okay. For these here one logic we need to learn one logic. We need to learn one logic. So we are going for develop this one. So I'm removing this. You have to create new project. You have to create a new project. You have to use new project. I'm deleting. I'm selecting all the connections. Okay. You have to use. Okay. Here they mention this one. Okay. Here we will use okay directly we picked here. Okay. Here I am selecting this one. Okay. Here just see here this connection only this one. First we will for 7 segment we will use the standard values A to G standard values. Okay. When we required when we want to blink first 7 segment, we will use 1, second 7 segment we will use 2. Okay, 1 2 values, accordingly it will blink. Okay, first we will select 1, second we will select 1. Okay, accordingly it will blink. So it is very fraction of seconds. So for that we are generating to blink another LED. We are giving some delay. We are generating some delay. We are providing some delay. Okay, we are providing some delay. Okay, so we are using same 8 connect pins. This is the standard values. We are providing these standard values. This is dot pointer. We are not using this dot pointer. Only we will use these two 7 segments, not dot pointers. Okay, first we will, if you want to use first one, you have to use 1, second one you have to use 2. Okay, here we will control these two. We will control these two connections. Okay, with that connection we will generate values 0 to 99 values. Okay, and when we are blinking, we need to give some delay, just a small delay. We are providing small delay. Okay, we will provide small delay. Okay. Same, which port here they connected. Here they are using P 2.6 and 2.7 for assigning SS1, SS2. Okay, 7 segment 1, 7 segment 2, 6 and 7 pins. Okay, we are using 2.6, 7 1, 7 2. Let's go. 6 1 7 2, 6 1 6 1 7 2. Okay, next they connected, they've written port 1. Okay, here they in code. Okay, I will explain code there. Okay, they are connecting port 1. They are connecting port 1. Okay, port 1. They are connecting port 1. I'm using same connection here. Port 1. I'm connecting 7 segment. Okay, this is the connection we developed. Excuse me. Okay, this is the connection we developed. Okay, next we are copying source code from manual. Okay, first they added one up to delay. Here they in manual they mentioned 2 times. First, here, first I'm copying first one. If you want, I will copy all and I will share with you. If you don't, someone, if you want anyone, please send me message, text message. I will copy, I will share with you in chat box. I will share with you this code. Okay, I'm deleting previous. I copied. This one is the S bit. Okay, first these two connections. Regarding these two connections, we used a S bit, S bit SS1. We taken 7 segment 1, 7 segment 2. Okay, 6 is connected for 7 segment 1, 2 is connected 7 segment 2, and this is delay code. Okay, next, in manual they mention void main. Control. Okay, okay, just I'm playing fast. Okay, just develop this schematic design. We will discuss source code. First develop, everyone develop this schematic design. We will, okay, we will discuss this source code. Okay, first develop schematic design. It's easy. Just develop this schematic design. We'll discuss source code. Okay, I will ask one question. Rishu Kumar, and Bhomik. Rishu Kumar and Bhomik. Just share me with me what have you, how to write source code. Just you said source code easy. Okay, just share with me your idea how to write source code. Okay, for this how to write source code. Only for two you are I'm asking. Just I'm not taking anything. Just you have any idea how to do the source code project. Source code development idea. Two students are already shared with me their ideas how to write source code. Two students already shared in chat. They shared. One is Annu Kumari. Annu Kumari shared her idea, and Saurabh Kumar shared his idea. You two also please share your ideas. How to do? Okay, this is the source code. schematic design and send me the message done. Then I will share with you source code. Okay. Okay. Please everyone complete the. I'm sharing with you source code file. Okay. I shared source code. Okay. I shared the source code. I shared the source code. Okay. Okay. You tried logic is right. Not right. Not right for all cases. Okay. Make you what you shared the logic. It is not coming all logics. Okay. It's not showing all logics. Okay. Array. You have to use array. You have to use array. Yes, everyone. Thank you. Okay. This, this is the source code. Okay. This is the source code. Now we are working on this source code. Okay. Now we are working on this source code. First, in in manual, our team in manual, our members mentioned 24 is a standard number. They taken 24 is a standard number. Okay. They taken 24 is a standard number. I changed it 27, but I'm making it 24. Okay. First I copied the source code. Just if you are just I'm telling you two things. If you want to learn schematic design, okay, first copy the source code and practice on schematic designs. If you want a source code, just copy the schematic designs, see the schematic designs in manual and s- experiment with source code. Okay, two processes. First I'm telling two processes also here. Okay, he shared a 24 number here. This schematic design is working fine. I'm changing the source code. I'm changing in source code. I'm changing 27 and I'm executing it once again. Here it is showing 27. Okay, this is source code. Just copy the source code and try to execute the source code first. Okay, here discussing source code. Here first we will develop schematic design with the help of schematic design. With the help of schematic design, we will develop our with the help of schematic design we will develop our source code. Okay, here he used two values p2 sig- here 1 and 2, 6 and 7, ss1 ss2, ss1 and ss2. Okay, this is ss1 ss2. Okay, here he taken delay, very small delay he taken. Okay, he taken delay, and just observe here, this is the delay. Up to here I thought that everyone understand. First he taken register 51 std.ioh, and he assigned one connection ss1. He connected 7 segment. Okay, he connected 2 pin to 7 segment, second pin to p2 seventh pin. Okay, delay, he generated small delay. Here delay is important, delay is important in this project, delay is important. Okay, okay, next up to here delay function he generated. Next I'm using here void main, he created void main. He created here I j k, four variables, three variables I k j, three variables, and 8 10 array 10 variables. Here we taken these standard values, common cathode standard values, we taken common cathode standard values. Next he assigned I value some. If you want to change any value, if you want to get any value, we need to try with here in we need to try here only, we need to try here. Okay, if you want change anything, we need to try here. Okay, okay, we need to try here I value, we need to try I value, we need to change the I value. This is the our actual value, what value we want to see. He's changing this value. Okay, here he's making this value displaying in 7 segment. Okay, next second one and third one, j and k variables are, just observe second and third one. J, he taken j is tens, 0 1. Here 0 1, he changed the value 0 1. He taken j is the 10th one place, 10th one place value. K is units value. Here it is first this one. Here he's placing k value here, j value here. Okay, but his standard value is 27. How he is making these is, here he taken int value, int he taken all three variables are I j k are int. I value is our standard value. If you change anything here, I'm changing 99 here. First I'm changing 99. Okay, here j should be first 9, here 9, 10th place, 10th position 9, and k is here units position 9. Okay, how is getting that? Is using operators, arithmetic operators. In arithmetic operators we have divide. If we int value, it is int value, that's why we are getting 99 here. First 9 we are getting is stored in j, first 9 is stored in j. And k value, here he using modulus operator, he's here he using modulus operator will give reminder. Modulus operator will give reminder. Okay, just here he's using his modulus operator to save the, to give the value here. Okay, this is k. So here replacing tens value, unit value into k, and I value there. Okay, then he's every time port 1 he's assigned a array value to port p1. Okay, he's taking he's enabling ss. First he's enabling units value, then tens value, like that he's enabling. Okay, he's giving some delay, he's giving some delay here in our in our project. It is very important, delay is very important, delay is very important. Okay, why? If you are changing the values, if you change without delay, you don't find the values, which value where it is coming we don't find. But when we are using delay, okay, it stays sometime, it stays sometime, it stays sometime. We are using while, so it is continuously rotate, continuous loop, so it will stay continuously, it will stay continuously. Okay, this is the code. Just I'm executing. Here it's showing 99, it's showing 99. Here I value, I changed the I value. Okay, please everyone, this is the source code. Some few seconds he's using ss1 ss0, he's changing these two, ss1 ss2, and he's using the source code. Okay, just I'm playing once again, just observe here. I change the I value. Okay, just copy the source code and execute it. Okay, copy the source code, execute it. dot point. DP is dot point. Here we have dot points. Okay. Here we have dot points. Okay. This is the 7 segment. Same way. Okay. Next one is common. Here, next one is common anode. Common anode. Okay. Next one is common anode. Okay. Next we are discussing common anode. Okay. Next one is common anode. Now we are discussing common anode. Here before we taken one value, one where we want, there we taken one, which led we want to blink, that led we taken one. Now we will take zero. If I want to blink zero value, this led here, previous case a b c d f g up to g we taken zero. Okay, zero, I want to blink zero. So previous case I used all ones, which led I want to blink. In common cathode we used one, common anode we will use zeros. Here, which bleed led you want to blink, there you need to use zero. Okay, like we created all zeros. With all zeros we developed a, with all zeros we developed all zeros we developed values here. Same way what we developed in common and cathode, same way we are developing anode also. On anode, common anode we are using zeros. If you want to blink particular led, particular led, there we need to use zero. Okay, so we used accordingly, we developed the values also, these x values. Same way we will. Okay, we have these values. Okay, next i'm using I'm using new project. We know that values. Same way, common cathode, seven segment, common anode, CA common anode with 8051. Okay, if you understand this, how to develop common anode cathode in every controller. If you connect the every controller, we will use same. We will every time we will develop our own values, and we will use those values and we will execute it. Okay. Okay, here next I'm picking 7 segment, seven, 7 segment, common anode. Here we are taking common anode. Okay, common anode, common anode. Okay, common anode, we are taking common anode. I'm connecting which port is mentioned in. Here also they mention port 1. Okay, I'm changing port 1 from here to, I'm connecting port 1. Okay, first I'm connecting port 1, first pin from here to port 1. Okay, okay, port 1, I'm connecting port 1. put one, and here there we connected ground. Here we need to common anode, we need to connect power source. Okay, here VCC, we select VCC, VCC, then click OK. We select VCC and click OK. Okay, here source code. First one, previous way. First one is delay. We copied. First we will take delay. Okay, here we copy delay. Here we take and delay. Copy delay function. Copy delay function and copying all. And take this delay. I'm copying delay. Okay. Then I'm copying void main. Okay. Copy void main. Okay, I copied. I used these same values here. Okay, here we are using for loop. We are using for loop. Okay, and we are executing simulation. We are start simulating it. Okay, it started simulating, and now I am running. Okay, it's working. Okay, this is the schematic design. Here, first you can complete this schematic design. Then we will discuss source code. First complete same connections, only components we change the components. Common anode, before we connected ground, now here we are connecting voltage turn. Okay, this one here we used CC, VCC. Here just develop this schematic design, then I will show you one more option. Okay, just up to here, please try up to here. Schematic design, and I'm copying source code. Okay, just complete this schematic design and copying source code in. Common anode, I shared a common and source code. Okay, I shared source code in chat box. Just copy the source code and used it. Use it. Okay, this is a schematic design. Okay, please use this one. Okay, develop this one. Schematic design up to here. Please use complete this one. Schematic design. I given you source code. Just copy source code there. I will explain source code now. I'm picking terminal mode. Terminal mode power. Using power option. I'm connecting. I'm using VCC here. VCC. Okay. Done. And simulation. Okay. I'm stop the simulation now. Here I'm just showing the. Okay. Now we will discuss. Okay. Delay. They created up to here functions. Okay. Main function. In previous common cathode source code, here everything is same. Everything is same. Only these values are changed. Only these values are changed. Remaining everything is changed. Same. Everything is same. Only these values. There we used common cathode. We used once, so we get different values. Here we use common anode. Here using we are getting different values. Only values will change. Remaining source code is same. Okay. And why we are using delay? Only for some if we are giving delay, that's why we are seeing LED blink. If we don't give the delays, I'm removing delay, we don't see the execution values. What value is coming? Only 9. Just it's coming 9. Change values are changing. It's continuously changing, but we not felt that. Okay, we are not catching that values. Okay, for that we are giving delays. Okay, so I'm removing the delay concept here. Here same way we are connecting int a, and we are taking for loop, and we are rotating the continuously inside the loop. We are rotating. Okay, we are generating these values. This is the common anode concept. Okay, just everyone please complete this common anode. Okay, everyone completed. Okay, same way in here I am using old project. You have to create new project. Common same way I'm executing common cathode 2 7 segments. 2 7 segments. Okay, 2 7 segments. I'm using 2 7 segments. Okay, common cathode 2 7 segments. Copying. I'm using common cathode. You have to use other common cathode. I'm taking 7 seg common cathode mx2 common anode. I'm using common anode. Okay. Before I used a common cathode, I'm replacing. Okay, only one value I'm changing. Here I'm changing. I'm taking this value from here in common anode single source code. Copy. I copied from here only that source code value. Here I'm pasting that. Here I'm removing. It is I'm doing. You have to create new project. I am using old one. You have to create new project. I'm changing 90, 97, 90, and I'm simulating it. So it is not working. Source code. Okay. I'm adding source code from there only. Deleting the source code. Connect. Okay. They modified source code also. Okay. Just take the schematic design. This is the schematic design. Everyone please create new schematic. We are taking attendance, no problem. We will take care attendance. This is the schematic design. Common cathode, 7 segment common cathode you have to use. Common CA you have to use, and you have to connect. Okay, accordingly you have to connect. Here, this is the source code. Here in previous case, here also same way they used 91. In J it stores 9 and K it stores 1. Okay, here they are providing J value there, K value here. Okay, everyone done up to here? Everyone done? Just in chat, just mention done. Okay, done. Next, just Here I will show you one more option called bus option. Here this one is the bus mode. I'm stopping the simulation. This one is the bus mode. I'm selecting this bus mode. Okay. Here I'm using bus mode. I taken this bus connection. Okay. Up to here I taken bus connection. Next I'm taking I'm deleting these connections, all these connections. I'm selecting and deleted. Okay. Here I'm selecting this 1, 2, 3, 4, 5, 6, sixth option bus mode. Okay, I'm giving here bus connection. Okay, here I'm connecting from here to here, here to here, here to here. Okay, here also same way I'm connecting here to here, here to here, here to here. Okay, I connected up to here. I connected. Okay, just see here. Now I am giving label. I am giving label to wire. I am giving label to wire. Here I am selecting this one. Here I am giving A. Sorry, A. Okay, A. Next one is I am selecting B. Okay, okay. C. Okay, okay. D. Next one E. F. Next I am taking Z. Okay, I given wire names here. Next here also. Here port P10 I connected A. So I'm making here A. I'm using A. Next one B. Next one C. D. E. F. G. I'm using G. Okay, I connected all these things. Next I'm playing the simulation. It's working. Okay, here this is the bus mode. Here this sixth one, the blue color line is the bus mode. Here if you connect data, we are sending data here to this bus mode. Here we are receiving here data here from this bus mode. Here mandatory thing is we need to give the name labels to wires. We need to give the labels to wires. This is the mandatory. This is mandatory. So if you have more connections, I have more connections, then I have I will face any problem. I'm facing problem. So in that case, we will use this bus mode. But some controllers have their own buses. Some controllers have their own buses. They will transfer data through buses. Some controllers. In 8051, I'm using external bus. Okay. In ARM7 controller have its own buses. Okay, this is bus mode. We will call it as a bus mode. Okay, here second one, this is the label, wire label. We will select the bus mode and we will connect from pin to bus mode. Then we will give the names to wire label. We are using label option, wire label. Then we will give the names here also. So accordingly it will transfer the data. This is the bus mode. Okay, this is the bus mode. Okay, just try this one. Okay, try this one. Okay, only we are not depending any pins. We are depending only on wires, only on wires. Okay, here no dependency, no dependent depending on wires, only depending on wires. Okay, this bus mode depending on wires, not on pins. Okay, only wires, it is depending on wires. Wire labeling, if we are giving wire labeling, it's working, not pins. If you connect any pin, if I will give wrong wire label, just I will show you. I'm using here wrong wire label B, output not working. Okay, so it is only it's working on with the help of wire labeling only, not pin. It is not based on pin, it is based on wire labeling only. Just remember that. Please share your query. If you have any query, please share in chat. Isha Gupta or someone raised a hand. Please share your query. Please. So we are not changing any source code in this project. If you are bus mode, we are not changing any source code. We are taking data with different format. Here wire labeling. We are using one option called wire labeling, bus mode and wire labeling. We are not changing source code. We are not changing any source code. Okay. Previous project, how we common cathode we used same way we are using. We are not changing any source code. We are only using this one only, bus mode. We are not changing any source code. We are using only bus mode. This is the schematic design. I told you now. Here, if you understand, this is the schematic design trick. Okay. This is the schematic design trick. If you have a more, just give the proper names. Give proper names. Labeling, wire labeling. Use this first. Draw the wire. Then um, um, I'm deleting these two connections. I'm deleting these two connections. Okay. I'm selected first. I'm selecting wire mode. I'm drawing. Okay, here also I'm drawing. Okay, first I'm connecting. I'm connecting wires. First I'm connecting wires. Okay, then I'm giving 2.6 A. Here I'm giving. Sorry. Here I'm next. I connected. Next I'm using label, wire label option. I'm clicking. I'm giving mm, H H. Okay, one H. Then I'm giving J J. Okay, sorry. I added this. Adding here wire label. In wire label, I am adding H. Then I am selecting J and playing the simulation. Okay, like this we will do. Here it only wire labels, helping wire labels, not pins. Okay, just remember this one. Okay, this is the process. Like this, if you have more connections, I don't want to connect all the connections. So in that case, we will use bus mode in Proteus. Outside also we have one option. Some controllers have individually. Try number format. I will check. I will stop the simulation. I'm deleting it. I'm deleting it. Wire label. I'm using wire label. I'm using one. Okay. I'm using two. Okay. Yes. We can use numbers also there. Yes. Just everyone take care. The wire numbers and everything. Okay. Okay. I'm sharing test. I'm sharing test. Okay. Here we just go any pin and stop the simulation. Go any pin. It will take. It will give the wire connection. It will give the wire connection. Select any pin where you want to connect. Go the tip of pin. Here you will get red. Then you can generate connection. Okay. That is the blue line is the bus mode. Here sixth one in these options, first one is selection mode, component mode, junction dot mode. Fourth one is label. Just remember fourth one label. Fifth, this is one text mode. Okay. Here this sixth one is bus mode. Just take the bus mode, select. First select the bus mode, draw the line. First one click. Okay. Select the line. Everyone who come, if you completed, just in chat send the done, sir. Send message done. Then I will share with you exam link, today's exam link. Please everyone send message done. Then I will send the internal. We are providing delay for not overlapping the digits. Okay, we are providing delay because of not overlapping digits. If it is not working, just try once again. Just everyone try that. I'm sharing. Okay, I'm sharing the test link. Please inform your friends also. Please inform your friends also this test link. Sorry. Sorry. Just complete the test. who are completed the test just leave the session. Okay. And some students yesterday they missed a test. I requested my director, okay, they will inform us one date. One day before I will inform you. Next day morning, 10 to 11 or 10 to 11, 10 to 10:30, I will arrange one day before I will inform you when we will conduct the test. Okay. I'm taking. Please, everyone send the mail. I will forward that mail to my director. Okay, my mail ID cybermotion technologies 4 at the rate gmail.com. Send that to that mail. I will share with our team and I will know how many members are missed the test, yesterday test. Okay. If you completed the test, just leave the session. Today's session is ends here. Okay. Tomorrow we will start new concept. I thought that everyone complete the test. Okay. Still, you want any help? Send me. Yes. Done. If you completed the test, just leave the session. Okay. Just leave the session. Please, everyone, take the test. I am sharing test link. Let's copy the test link. Everyone complete the test.